Hello everyone! This guide focuses on shooting and projectiles in Miliastra Wonderland. You will learn how to create a simple tower defense game, build single target and multi-target towers, create local projectiles using skills, understand projectile motion devices and projectile on-hit detection, add abilities and much more. Additionally, you will learn how to add tap, collision trigger and VFX components to objects and edit their logic in node graphs. This guide will also cover how to create a fully functional tower building platform. To create a working projectile, go to the prefab library, select the object you want to use as your projectile, and add the projectile motion device component to it. There, you can choose the projectile type: linear projectile, parabolic projectile, tracking projectile, or radial fire. Linear projectiles travel in a straight line. You can modify their initial speed, acceleration, and acceleration duration. Parabolic projectiles follow a parabolic trajectory. You can again adjust their initial speed as well as the gravitational acceleration, which essentially determines how strongly the ground pulls the projectile downward. Tracking projectiles home in on a target and are often the most useful type for tower defense games, since towers usually should not miss their targets. In addition to initial speed and acceleration, you can modify the tracking angular velocity, measured in degrees per second. If you want your projectile to almost always hit, set this to a high value. You can either manually assign a tracking object or specify it via a node graph. Later I will show you the node graph method I use. Radial fire is very useful when you want a projectile to orbit around something. When I made my previous game, some players asked, how can you make these spheres orbit around you? You can't add both a basic motion device and a follow motion device at the same time. And that is true. They are mutually exclusive. Radial fire solves this by allowing you to select an object, or the player, causing the projectile to orbit the target with a specified angular velocity. You can also adjust the circumradius to make it orbit closer or farther away. That was the very first step in creating a projectile. If you want your projectile to actually deal damage, some additional setup is required. Start by adding an on-hit detection component to the projectile you already created. One of the most important parameters here is trigger type, and it is crucial to understand the differences between the three options. Single trigger. The on-hit detection triggers only once during the object's entire lifetime. This is useful for things like a large bomb that should explode a single time and then be destroyed. Non-repeating trigger. On-hit detection triggers once per hit entity. Repeating trigger. The on-hit detection can trigger multiple times, with the interval controlled by the trigger interval parameter. When an entity is moving at high speed, you may want to enable continuous collision detection, but this is often unnecessary and comes with a significant performance cost. Local filters are used to determine whether the current hit is valid. They are evaluated every time a hit occurs. More on local filters will be explained later in the bonus part of the video. If you want on-hit detection to work only on specific objects or creations, for example, in a tower defense game you may not want your towers to hit the player, only enemies, you need to enable filters. There, you can set options such as the faction filter to hostile faction and the entity type filter to only creations. In a separate window, you must also specify an on-hit area. Everything described above will only be applied when entities enter this defined area, so make sure its size is appropriate for your needs. Next, we need to add ability unit to our projectile, because we want it to deal some actual damage, not just fly without doing anything. Click on your projectile, go to the second tab, and find ability unit. Then click Advanced Editing and Plus. At the very top, you can rename your ability. Then you need to select ability unit from three options. Hitbox attack. Initiates a hitbox attack on a specified target or location. When the attack hitbox collides with an entity's hurtbox, it launches an attack against that entity. Direct attack. Performs a direct attack on a specified target. Recover HP. Pretty self-explanatory. Restores a specified amount of HP for the target. When choosing direct attack, only the attack parameters and VFX tabs will be visible. When using hitbox attack, you will also need to configure hitbox configuration and target filter. First, enter your desired damage coefficient and increment, then choose an elemental type or leave the attack elementless. Next, select the hit type, which determines the hit sound effect and the default hit visual effect. If you choose a smash attack, it will additionally reduce geoshields and trigger the shatter reaction. You can also set the attack to deal true damage, meaning it is calculated only from the damage increment and ignores both the attacker's attack and the defender's defense. The hitbox attack configuration and target filter work similarly to the on-hit detection filters mentioned earlier. For example, if you set the filter target faction to hostile faction, the attack will only be considered valid when the hitbox collides with an entity from that faction. Likewise, if you set the entity type filter to creations only, the attack will be valid only when the hitbox hits a creation and not, for instance, an object or a character. After you finish making an ability, you need to go back to the on-hit detection component, find on-hit trigger settings, and under Execute Ability Unit when hit, click on Add Ability Unit, and select the ability you just made. Next you need to make a very simple node graph. Head on to Beyond Editor and go to Server Node Graph, Entity Node Graph, Uncategorized tab, and right-click on an empty space and select Create Node Graph. Connect when attack hits to destroy entity and event source entity to target entity. This node graph makes the projectiles disappear after attacking their target and dealing damage. You need to mount the node graph on every projectile you make, unless you don't want them to disappear. Congratulations, you now have a fully working projectile that flies and deals damage. Now we're left with just one big problem. Nothing is yet launching that projectile, but we'll fix it. Now that we have a working projectile, we just need to make a projectile launcher. In a tower defense game, these usually will be towers. So let's make few kinds of towers now. Single target, multi-target, explosive, and debuffing. Let's start with multi-target towers, since they are the easiest to make. Laser tower from my game will serve as an example. Choose a tower model, in my example it's metal mechanism object, and add an on-hit detection. Set trigger type to repeating trigger, trigger interval to whatever you prefer, and this time do not add any abilities. The tower itself won't attack, it just serves as a spawn object for our projectiles. Set on hit area as you like, and for the second time in this guide, we will need to work on node graphs. This is a very simple graph that connects event node when on-hit detection is triggered to execution node create projectile. What this node graph does is it tells our tower to create a tracking projectile every time an on-hit detection is triggered. 3D vector addition you can see is not needed, it just makes the projectile start from the top of the tower instead of the bottom to make it look better. Otherwise you can just connect location from get entity location and rotation to location in create projectile. You may remember that I mentioned earlier that if you make a tracking projectile, you can set the tracking object manually or through the node graphs. This is how you can do it. Just connect on-hit entity to track target in create projectile. This way your newly created projectile will always home in on a target entering the on-hit area. What you also may notice is that when more than one entity is inside the on-hit area, the projectile will be created for every single entity inside. So, if you want to make a single target tower, you will have to make some adjustments. So, let's try making a single target tower now. Most of the process will be identical as before, the only change will be in the node graph. This looks a little more complicated, but it's really not. We basically look for all entities in a specified range around the tower, same range as the tower's on-hit area. Then filter only creation entities, because we don't care about objects or characters. Then we take a list length. If, for example, 20 enemies were in range, then getListLength node would output 20. And check if it's not empty by using equal node and comparing the integer to 0. Then, if the list is not empty, we compare on-hit entities, which are enemies that enter the tower's range, to the first value from getEntityList by specified faction. And there can only be one match at a time, so when that match is found, the only single projectile is being created directed at that one entity. If it dies, the node graph will automatically find the next target. To create explosive projectiles for explosive towers, you just need to make sure the select ability unit is set to hitbox attack and that the hitbox in hitbox configuration is much larger than normally, so that the explosion can hit multiple enemies. You can also optionally add some explosive VFX and sound effects in the on-hit performance tab to make it look and sound like a real explosion. The last tower type I wanted to showcase is the slowing tower. It doesn't use any projectiles, instead it uses unit statuses and collision detection. To make one, we need to first add a collision trigger component to our tower. We need to set it to initially effective and effective target to creations. Then we need to go to the combat preset, choose unit status, and click on plus new status. In basic settings, we set maximum stack layers to 1 and infinite duration. and in the effect details click on Add Effect and search for Movement Speed Adjustment Rate. And set it to -40%. Now copy the configuration ID on the status and let's again head to Beyond Editor to make a new node graph. Pretty easy to understand node graph. When enemies enter the tower's collision trigger, they will be applied a slow debuff as long as they are inside the tower's range. Mount Looping Special Effect node just adds some visual cue that the enemy is currently slowed. When exiting the tower's range, the debuff will be cleared. That's everything about creating server-side projectiles, projectile types, projectile on-hit detection, hit triggers and unit abilities. But we still need to talk about one more type of projectiles. Creating projectiles with towers, cannons and other objects is already pretty cool, but imagine creating them using skills. It's a bit more complicated, but nothing we can't handle. Let's dive into local projectiles. First, go to the Combat Preset tab, select Local Projectile on the left, and click plus Add Projectile. Choose a model. I recommend empty object, so you can create something impressive using VFX. In the attribute settings, select Inherited from Creator. If you want your projectile to disappear after a set time, specify a duration, otherwise choose Permanent and adjust the component axis destruction distance. Projectiles will vanish when they exceed this range. Now switch to the second tab. You'll see your projectile already has 3 key components by default: VFX Playing, Projectile Motion Device, and On-Hit Detection. Since we chose an empty object, select one or more VFX to make it visible. Click Advanced Editing. Note that only looping effects are available here. For this tutorial I chose 2 VFX, Electro Trail with a zoom factor of 2 and Mist Bubble. Preview how they look together by clicking Preview Combination and selecting both. The projectile motion device and on-hit detection work the same as before. Choose your desired projectile type, speed, acceleration, trigger type, and don't forget to add an ability unit via the third tab. Now add a skill the player can actually use in-game. Go to the third tab on the left and click plus new skill. Here you can set the skill's cooldown, usage limit, or resource consumption. Then select Animation Editor. First, choose a basic animation for your character when activating the skill. Pick whatever fits your projectile best. For this tutorial, I selected General Quick Chant 01 because it's quick and fluid. Then we need to stop for a second and create a client node graph with our previously made projectile. All the previous node graphs we made were server-side, but this one is not. And to access it, we need to go to our Beyond editor, select Window, and then Client Node Graph Resource Explorer. Then go into Skill Node Graph, uncategorize tab, and finally right-click on an empty space and select Create Node Graph. Some nodes are only available in client node graphs, which can be confusing at first, but this one is straightforward. Simply connect node graph start to fixed point projectile launch, and paste your previously created projectile's prefab ID. The rest involves ensuring the projectile launches from a specified attachment point, and on that note, creating a custom attachment point on your character will look much better than having the projectile spawn from the head or torso. Let's quickly add one now. Go back to Combat preset, select the first tab on the left, Edit Character on the right, third tab, under Custom Attachment Point click Advanced Editing, add Custom Attachment Point. Name it whatever you like, I used Skill Attachment. Set your desired offset and rotation, and you're done. Copy the name and paste it into the client node graph we started earlier. Now position the node graph to sync with the animation. Return to the animation editor. Use the blue flag to preview the character's animation frame by frame, and decide the perfect moment to launch the projectile. Optionally, add events like VFX Playing to your character during the cast by right-clicking empty space in the status track and selecting Add Event. When everything is complete, save your projectile and skill. Then go to the Player tab in Combat preset, Class, Custom Class, second tab on the right, set active skill quantity 1 and add your newly created skill. This covers everything I wanted to show you about shooting and projectiles in Miliastra Wonderland. As a little bonus, I will now also show you how to make a fully functioning tower building platform. Let's start by selecting the main model of our platform. In my case, it's the stone functional platform. I made it a little bigger by modifying the zoom factor of X and Z axis. Next, let's add all necessary components: tab, collision trigger, and VFX Playing. Select Advanced Editing on the collision trigger component and select Initially Effective and Effective Targets Characters. If you want to make multiple platforms next to each other, I strongly recommend making the collision trigger area much smaller than the platform so that there is no overlap. My previously made towers are separated into categories: Tier 1, 2, 3 and Special Towers, so I made separate tab option for each of them and made them initially effective. You may not need that many options, so feel free to adjust to your needs. There is also another tab option we need to add called Destroy, but this option can't be initially effective. We need to show or hide it on demand. Your trigger option area for tab component should be the same size as previously made collision trigger area size. The easy part is now over. We need to make a working deck selector and working logic in node graphs. Select the main menu and click on Manage UI Control Groups. Then UI Control Group Library and click on Add UI Control Template, Deck Selector. Select that little arrow and click on Panel. There you can enter title text, for example, select tower to build. Tweak available options to your liking, but make sure selection can be cancelled is checked, because we don't want to force anyone to make a decision each time they invoke a selector, especially when towers cost some sort of resource. When you're done with the first page, head to Option Configuration and start adding your towers or objects to the deck list by selecting Edit Details. For each tower you want to add to the deck, you need to click on New Row. Make sure deck type is set to Known Deck, then add a deck icon, title and description. Optionally also change its tag color. When you're done, select Save as Template and you're good to go. If you also want your towers to have a resource cost, go to the Combat preset, then Edit Player, second tab, and under Custom Variable, select Advanced Editing and select Add New Variable. Name it, for example, Gold, change its type to integer, and select the amount you want players to start the game with. Everything else will be done in node graphs, so let's go back to Beyond Editor. This is the first node graph we need to mount on our platform. Its purpose is to invoke the specific deck selector when choosing the appropriate tab option. If you made only one category of towers, you will need only to invoke one deck selector here. Each deck selector needs its own deck selector index. You can find it in the Manage UI Control Groups window. I recommend setting select duration to a high value here unless you want your players to make quick decisions. Target player should be connected to affiliated player entity in the Get Player Entity to which the character belongs node, and the character entity will be the selector entity from when tab is selected. Since we want the player to select only one tower at a time, select minimum and maximum quantity should be set to 1. Also, we don't want the player to refresh the selection, so set it to 0. The last and most important part here is the assembly list connected to select result corresponding list, select display corresponding list, and default return selection. Make sure your assembly list type is set to integer and the output list to integer list by clicking on the cog icon. Then you need to make sure the numbers of your towers you entered into your deck selector and the numbers of IDs in assembly list match. For example, if your deck selector contains 3 different towers, your assembly list must have exactly 3 rows. You're now done with this node graph. Remember to mount it on the platform and let's look at other necessary node graphs. Before I start explaining what's going on here, make sure you mount this specific node graph on player entity. You can do so by going into Combat preset, Edit Player, Node Graphs. If you mount this node graph on the platform like you did before, it will not work. This node graph looks daunting, but once you understand what's going on, it's just the same process repeated for every single tower you have. Let's start by creating our event node, when deck selector is complete. Then we need to make sure enumerations are equal and that the deck is indeed invoked and completed by player. Then we need to make sure the deck selector index matches, because we want the event node to trigger only when we complete a specific deck selector, not any one of them. Next step is creating a multiple branches node and connecting control expression to value in corresponding value from list. The list being taken from selection result list. If you followed my guide and entered numbers from 1 onward to your assembly list, for example 1, 2, 3, this will be your order here as well. So if your first tower made in deck selector was a pyro tower, the first option in multiple branches should be the one to create prefab of your pyro tower. If you don't want your towers to have any cost, you can skip the next part and go straight to create prefab node. Copy and paste the prefab ID of your tower in slot 1. Getting the location and rotation of your spawned tower is a little trickier here, because you probably want to create it perfectly in the middle of the platform, not just in any random spot. To make it happen, you can connect target player from when deck selector is complete to target entity in get entity location and rotation. Then you need to create a query node, get entity with specified prefab ID on the field. Your prefab ID will be the platform's ID. Then connect entity list and location to get entity list by specified range node. If you made the same looking platform as me, set radius to 2.8. Otherwise you will have to find a radius that works for you. The goal is to query all platforms available on the field and get only the one the player is standing on, no more and no less. So the radius has to be small as possible while also consistently working even when the player is barely in the collision trigger. That is another reason I previously recommended to set the collision trigger area to a much smaller size than the platform. Connect result list to get corresponding value from list. Set ID to 0 and value to get entity location and rotation. Since the platform is quite thick, you may want to spawn the tower a little higher, and you can use the 3D vector addition node to do that. Otherwise, just connect location and rotation to create prefab node and you're done. If you want your towers to have a resource cost, you will need to implement a resource check and subtraction, and this is a perfect moment to learn about composite nodes. If you think this node graph looks scary, it would look a lot worse if I didn't use any composite nodes. Composite nodes allow you to put many different connected nodes into one, decluttering your node graphs and making your work easier. Let's try making one now. Try creating the nodes you see on screen. It's just a simple mechanism to check if the player has the required amount of gold to build the tower, in this example 10, and if they do, 10 gold will be subtracted from their wallet. If you named your variable something other than gold, you need to change it here too, both in get custom variable and set custom variable nodes. After finishing, select all these nodes and click Generate Composite Node. First, select the executive pin in double branch and right-click Set as Composite Node Pin. Do the same with executive pin in second custom variable. Your composite node now can be connected on both sides and it will work and execute the logic within. But what if we wanted our towers to have different costs? We could select write value from greater than or equal to and subtraction value as pins also. What's even better, these two values will always be the same, so we can merge them and save ourselves some time. Click on any of these pins on the right side and select Merge Pins. Select which pin you want to merge and select Confirm. Now whenever we type any value, it will automatically apply to both these nodes at once. You can also rename your composite node by clicking on Create Composite Node 2 times. That's it, you just made your work a lot easier. One more composite node I use is the one activating and deactivating tabs on our platform, since after we build a tower, we no longer want to see the building options there. The only option remaining should be Destroy. Similarly, when destroying a tower, we want to have all the building options available to us again on our platform. Next, we'll look at destroying the towers. If you don't want to add a destroy mechanic to your game at all and make all placed towers permanent, you can skip this part. To locate a tower we want to destroy, that means the tower directly above the platform, we need to do a similar trick we did before with placing the tower in the middle of the platform. This time I will show you how to do it using unit tags. Select your tower in Prefab library and under Unit Tags tab, click Add Unit Tags, and then open Unit Tags Management tool. Then create new unit tag, name it however you want, I use tower. Copy the index and let's go back to our node graph. First we need to make sure our node graph reacts only when we click on the destroy option, so we need to locate its tab ID. If your tab list is identical to mine, destroy option will have ID 5. Otherwise, click on your platform and look into your tab component to locate its ID. Then create a node getEntityList by unit tag and paste the unit tag that you copied before. Once again, you want your center point to be the platform itself, so connect event source entity to target entity in getEntityLocation and rotation node, and location to center point in getEntityList by specified range. Then take the first value from that list by using getCorrespondingValue from list and pass it to destroy entity node. After destroying a tower, we need to make sure that building options are available again and destroy tab is hidden. If you previously disabled platform's collision trigger after building a tower, you also need to make sure you enable it again now. I saved the easiest part for the end. You can use collision trigger on your platform to make a nice VFX every time a player enters the platform. Create a play timed effects node and connect it to when entering collision trigger. Set the target entity using the getSelfEntity node. The default attachment point root node works fine. You can select your own VFX. I chose yellow warning barrier for mine and also change the zoom factor a little. Remember to mount the node graph on your platform and you're good to go. You now have a fully functional tower building platform that can create and destroy your towers and also look great while you step on it. In the last part of this video, I want to show you a very simplified version of this platform. It can't be copied endlessly like the previous one, but maybe you don't want to build a whole tower defense game and only need a single working platform. This is also a great idea to showcase local filters, but first let's try adding another custom variable to our player. Head to Combat Preset, Edit Player, second tab and click on Advanced Editing under Custom Variable, then add another variable and change its type to integer. Name it however you want. I chose hidden points because we won't ever show this variable anywhere and it only exists for the purpose of the local filter. Next, head to your newly made simplified platform and add a tab component. Again, add however many options you want and a destroy tab at the end. You may see under every tab you can select local filter and filter node graph. Since we created a custom variable that is an integer, let's change local filter to integer filter everywhere. Now let's go back to Beyond Editor and once again head to Window, Client Node Graph Resource Explorer, Integer Filter Node Graph, and right-click Create Node Graph. As you can see, it already comes with a node graph and integer, and an output result. This is a value that will be checked every time we come close to our platform. We want that node graph to check for the value of the variable we just made, so let's connect getCurrentCharacter to getPlayerEntity to which the character belongs, and then to getCustomVariable. In my case, variable name will be hidden points. Save your node graph and select it in Filter Node Graph under every single tab you made. We now need to add integers to our integer filter variable list, so we do it by clicking on the plus button. In my case, I want the first two options to appear when my hidden points variable value is set to 0, and the destroy option to appear when my hidden points variable value is set to 1. You can of course choose different integers for your needs. Now we just need to modify the hidden points values using node graph, so let's go back to our editor. If you've been following closely, you probably understand perfectly what's going on here, but just to recap. When we select the first tab option, in my case it's building a tier 1 tower, we want two things to happen. First, we obviously want our tower to appear, and we do it using create prefab node like before. And the second thing is setting our hidden points value to 1, so that our building options vanish and destroy option appears. Target entity in set custom variable node is taken from get player entity to which the character belongs node, and character entity is taken from selector entity. The second tab option in my case is nearly identical to the first, just need to remember to change the 1 value in the equal node to 2 this time. And the prefab ID in create prefab will be different. My third tab option is destroy, which means that after selecting it, I want to set the hidden points value to 0, so that the building options appear again. Other than that, the destroy mechanism is identical to the one I showcased earlier in our main platform section. Need to use unit tag for it. And that's how it works. This guide turned out to be way longer than I previously anticipated, but I hope you learned something from it. Thanks for watching.